right here. Thought we've been working with Rust for a while now, and we haven't been using any Rust-specific extensions in Visual Studio Code. So what I thought I'd do is I'd demonstrate, go through why one might want to consider using some extended functionality, and then what it would be useful for. So let's get into it. So anyway, there's basically two types of extensions available that could be useful. There are static code analyzers, and then there are those that are used for debugging Rust code. And Visual Studio Code does not have any support for debugging Rust code, but it does have some built-in support for the editor functionality. So I'd like to go through a few points that are not supported in the standard Visual Studio Code. So if you take a very careful look at this code, then you notice that it has several problems, and just looking at it like this, basically you can't see anything until you actually try and compile it, and then you will get a litany of issues. So I just run the build procedure on it, and as you see, we get quite a list of things in it. It would be useful to be able to be told in advance that one has problems, so one can fix it on the line that one's working on. So anyway, getting down to the nitty-gritty. This Visual Studio Code, it basically has no syntax checks or highlighting. For syntax errors, as you see that it has code highlighting, but not directly for syntax errors. And then there's no correction hints, like, okay, if it notices you're making a syntax error, then it can't display what it would suggest you to do. And it also has limited auto completion. So let's say we can go in here, we can say print, and then okay, it does do a search of names that you could possibly use, and then you could use the name ln, but it doesn't take into account that this might be a macro. And then it also it can't display any parameter list requirements. So it can do some extent auto parentheses, or auto brackets, but otherwise it hasn't got much. And also that if you haven't imported the function that you put here, that you need to use some kind of use statement to pull it in from a module, and it doesn't give you any hints as to where it could be imported from. Also, there's no context-based document review. So if you write print ln, then there's no possibility to bring up directly embedded documentation for the function in question. You can't ask it to display the definition of the function you're using. So here you can go here, and then there's nothing really here that you can use. So there's no show definition. You can't find references. So if you have a variable that's used if you envision this code to be very long, and then you're using a in very many different places, then you can't say okay, show me all the references. Like, where is this variable used? And then there's no on-the-fly displaying of extra metadata about the objects that are being defined in your programs, which is sometimes used. So what I think we will do, or my idea now, is that we will activate the extension that I usually use. Now there's lots of extensions. I'm not saying this is the best of the lot, but at least in my testing, it's been reasonable. And with extensions, I did do a demonstration of this when I was talking about Visual Studio Code in general. But there's you can enable this per workspace, um, and that's what I usually do when I'm working on different things. That I actually keep the extensions by default, all of them by default disabled, and then I only enable the extensions I need on a per workspace basis, depending on what I'm working on. But the one that I use is called this Rust Analyzer, and without going into the details, it pretty much does all the points that I said that Visual Studio Code can't do without it. So if we just go in here and then we say enable for this workspace. Now it's sometimes I've noticed that you might need to restart Visual Studio Code. You should be able to dynamically disable and enable extensions, but sometimes it messes up. And then also I've noticed that you may need to actually save the file. Even if you haven't made any changes to it, you need to save the, like in this case, the main file to get it to actually scan it again. So I've had a little bit of limited inconsistent behavior sometimes with this extension, but it actually does a pretty good job. So if we have a look at our original complaint list, no syntax checks or highlighting, and so here we see that it doesn't like the type being used. It's in type with a similar name exists, and then this also it tries to actually find what is the closest thing to what you're trying to define. So so this should be actually 8. Okay, that makes more sense. And here we see that it's still flagging it as incorrect. So sometimes it will, after a time, it will rescan it, or you actually have to press save to get it to. And then here it thinks there's some problem also. So we need to add that. And let's see if it catches the next problem. Yep, it did. It does. So it stops. One of the features is that if you have multiple syntax errors, then it will usually only display one at a time in the line in question. For example, this one should be. Let's see what it suggested. Expected function found macro println not function. So then it actually tries to give you a whole bunch of information. It says that you need to have this as a macro. So quite useful. And again, we need to save it. And then it also says that you need to have a formatting specifier. So let's get that also added. Oh. Save that. And now it seems to stay valid. And then this is valid. And then here we also have basically I can just correct it. Already show here. It also pops up with a display showing what it's about. Specifier. Just to get rid of that. Let's see. So that was limited auto completion. So this would be. So now what we can actually do is we can do this print. Okay, we can start from the beginning. As you see now, it gives you the list of everything that's available, and then you can select that one, and then it delves into the documentation for it. Oops. you start the parameter list. Oh, it didn't work so good, this one. Doesn't seem to want to get the parameter list analysis. Okay, that was a surprise. I thought it would have actually been able to catch that list. Let's see if we destroy it again. Oh. Okay, a little bit mixed mileage with that. I thought it would actually pop out with us the. But of course, println it has a dynamic parameter list, so there's no, so maybe from that perspective, it's understandable that it can't really show what the parameter list is. Yeah, and then this is also doing this kind of checking that is it initialized or not. Let's see if that makes it disappear. Ah, damn, I forgot to make it mutable. Rust. Oh, it's complex. Oh, well, that fixed. So it seems to have some more support to, so you don't forget stuff. And then this was this metadata viewing that now when it's cleaned up, then you can actually get metadata. So it tells you that, aha, this is, what type is it? Even if we're down here right in the middle of the code, then it can actually tell you what is this. And then go to references, and here it actually shows you the reference list, which is very useful so you can know where it's being used. Go back to my complaint list. So syntax error handling we did, auto completion stuff, documentation show the definition, find the references, and then on the fly display of meta information on objects. And then it seemed to have this extra capability to actually, for example, if the variable is not mutable, then it was warning that you can't use it in this context. And then if the variable is not initialized, then it also captures those, or it analyzes in the background and tells you that you haven't initialized the variable. So there are a whole bunch of other features that this extension has, but these are them. I wanted to keep this video kind of short and simple, but so these are the main reasons why you would possibly want to enable this extension, because it can actually make your coding life a bit easier when we get into larger projects and more code. So let's have a look at debugging. And let's see. Okay, let's say start debugging. And as you see, there's no built-in debugging, so it expects you to give some command to be able to do the debugging. But there is an extension for this one also. And this I have been using for debugging. I've been using this one, code LLDP, and then we enable it for the workspace. And then we go back to files, to this one, and let's put a breakpoint there. let's see what happens now when we say start debugging. Oh, let's take a little bit of a look at debugging in practice. So, if you actually have a clean environment where you don't have the target folder and the executable hasn't been created, then you actually need to run the build process first. And let me see, we go target debug, and then you see we have the executable here. And this is the debugging target. So then you need to go up to this launch.json and tell it what file you want to start up when you start debugging. So here we basically you have to add this here. In my case, it's to add that to the workspace. So it starts from the top here, and then you go extensions, target, debug, and then extensions.exe. And then you can go to this section here, and then you can say okay. And then we see the breakpoints here. I just added one to the code. I can actually bring up the code. And then we can say that we want it to start debugging. And then you have a breakpoint there. And when you're debugging, then you actually get access to the, I mean, if you're not very familiar with debuggers, then this might feel a bit confusing, but for those that are more into debuggers, you basically have all the standard functionality. So you have the local variables, you have if you have any statics, it'll show the values, the globals, and then registers, which is actually kind of interesting that you actually get these, but if you want to go down to the processor level, you can actually do that. Not that that's super useful when you're usually when you're dealing with the normal Rust programming, it's not that useful. And then you have a call stack, so it will actually show you where what stack has it gone through to get where it is. It can be interesting, like you can see. Let's see if we can find. So it basically starts here. So you can see where it starts, like the language start, and then it goes to language start closure, and then backtrace Rust begin short, and blah blah blah. So that's all the initial stuff, and then it ends up in main. And you can also look at on the fly, look at what the variable values. So when and then of course there's the option to step through stuff. Let's see. Where did they put that? Ah, yeah. Let's see. Step over, step into, step out. So then you can actually go into the. So now you actually get directly access to the actual implementation of the inline function. If you're interested in that level of detail, more like geeky stuff. And then you can put a breakpoint here, and then you can say continue, and then it'll end up in the next breakpoint. So step into start, okay. And then you can restart on the fly. So it comes into main, and then ends up there. It's disconnected for other things. And then you have breakpoint monitoring here, and then you can add function as a breakpoint so that you can say that it should break in very specific conditions. Usually you can expect. And then it shows you all the modules that have been loaded. Excluded callers. What that is right now. Oh, that's interesting. A little bit of extra information about each Windows DLL that's loaded. And you can say, actually, the most useful of this list here, if you got more of these modules, then you can actually see where you're successful in loading the symbols, even for your own stuff. Sometimes you wonder why can't I put a breakpoint, or why is it not displaying the correct, and then you find out there are some messed up symbol tables. So that was a general overview. I think yeah. Of course, it depends what kind of code you're making and stuff. But I think the most useful part is the syntax scanning stuff. So this Rust analyzer is pretty much the most useful. And then secondary, if you need to do debugging, then the code DB does quite a good job of debugging. And plus, the thing is, it can also, haven't tested it myself, but if you have a C++ Rust combo or C and Rust combo, then you can actually use this debugger to handle both situations at the same time. So that's quite good, and it gives you all the basic features you need. You can set breakpoints. You get the value of all the variables, and you can step around and doing the normal stuff. Then it was to actually add a watch point. That was one thing, right? I forgot one of the basic functions. Having a deep, so you can actually add what you want to monitor, of course. Just jumped over it. I don't need that. What do you need that for? That's actually one of the drawbacks when one is so used to using different development tools and stuff. Then when one tries to explain it to somebody else, then one is like, one doesn't take the more self-evident points that maybe somebody doesn't really realize. But as I said, I've used this a bit, and I think for the level of stuff that I do, I think that it's quite useful. And as I said, there are many more extensions that some of them, there are various different qualities and stuff. But I think I selected these because they're basically stable and are quite popular. And then, of course, for some, you probably might find some tools that are better for some niche type operations. But these will get you started and actually help you do coding. So I hope you enjoyed that one, and I'll see you in the next one.